Hey, good evening, everyone. Welcome to this new week. Um, for this week, we'll start talking about memory and context management in AI agents. And as usual, we will start the class by having a recap of the previous week, the previous class. So, who can help give us a recap of um, direct and conditional edges, edgeless graphs, and common pitfalls and best practices? Any volunteer? No volunteer? Am I audible?
So you're audible.
Okay. You don't have to talk about all. You can just talk about an aspect and then someone else talks about another aspect. But if you talk about all, that's fine. Anything you want to?
Yes, I want to.
Okay. Go ahead, please. Thank you.
Um, we touched on a fixed edge. We touched on the conditional edge, and we also touched on routing function and a path map. So the fixed edge is a hard coded connection that defines a permanent direct path between two nodes. And conditional, so I mean that they allow the system to branch, to loop or exist dynamically at a specific runtime. And we also spoke about a routing function. A routing function, to me, if I'm to have a phrase that I could grasp it in mind, I want to. It is referred to as the decision function. So it's the logic that determines which node or agent should execute based on the current state, and it returns a key. So when this key is being returned, the path map um, gets this key, and it will determine. So the path map uses a dictionary format. So that is a key and a value pair. So um, it gets the key. It gets the key from the routing function, and it associates it to the um, like to the real value. So maybe if the key is maybe validate, it will associate it with a specific value which binds the key. So now that would be for that, and we spoke about common best practices and best lab practices might use, and you and like you suggested that our routing function shouldn't be over like too complex. It should be simple. Like we shouldn't overcomplicate things. We should avoid endless looping, and our precursions should also have a number that it recurs with. So this is what I recall. This is what we did. If you throw some light on it, or you correct me on certain things, I'll be glad. Yeah, thank you very much.
Okay, that was a good one. Does anyone else have something to add before I'll do a final recap if necessary? No one. Okay, so I'll just add that the path map it maps the key that the routing function returns. Okay, Adobe. All right, go ahead.
Yes, let me just briefly touch some of them. I believe it also helped me to recall and remember most of them once again. So we did edgeless graph pattern. We talked about a central dispatcher node that acts like a router or manager, and then how it works, how it uses an LLM to decide which expert node that is the best, and how it returns a command that's pointing to that expert. Also, we talked about land graph command objects and a special objects which returns mostly is returned by nodes, and it tends to control the state updates and where to go next. Also, we talked about managing handles and dynamic returns, and you said that for the problem after an expert finishes, and you also talked about how does he know where to go next, and for the solution, the dispatcher stores the return destination in the state, and then the expert reads that value, and then the expert returns a command. And then we talked about the best practices for an edgeless graphs, where we talked about node naming, the use of consistent clear names across the app, and then the safety and clarity, also state management, and then some of the risk. For example, if a node doesn't return a command and when there's no edges, that's the graph may stop immediately. Yes, that's all I can say.
That's quite a good one. That covered some of the parts about the English graphs that Kenneth missed. Like I was trying to say earlier, the state, the path map, it maps the key. Its key is the response from the router and the routing function, and it maps that key to the specific next node. So it's simply a dictionary of keys to nodes, so that when the routing function returns the key, the agent knows the next node to go to based on the mapping between that key and the node. Yeah, that's one thing I remember. I know there was another thing I wanted to say, but it's fine. I mean, when it's something that you can easily, when I recall, I'll say that, but probably that will come up again sometime, and it's okay. Besides, there's still the video for us to go back to and watch to refresh ourselves. Okay. So today we are looking at memory. Why do agents need external memory? Why? I mean, why don't we just go ahead? why do we add this complexity of external memory to our agents? I mean, like we've mentioned before, LLMs are stateless. They don't remember. And that's what I'm referring to here as the amnesia effect. So once an LLM finishes processing one request, it doesn't remember anything about that request when it's given another prompt. So each time you give an LLM a prompt natively, it doesn't remember what happened before. It doesn't remember the history. It treats each new prompt as a fresh thing, right? But then we know that that doesn't really add much value. You need the value of the LLM's response really improves when it has context, when it can remember things, when it can remember history and so on. And of course, there's also now when I say when it has context, now I'm referring to the surrounding information. I'm referring to the history too. Now there's the problem too that LLMs have token limits, so they have a context window. How much context can you provide? It's limited by the token limit of that LLM. And so it's sometimes it's not feasible to provide the entire context. Context here refers to surrounding information about whatever the user's prompt. So you may not be able to provide the entire context all at once to the LLM because, well, you can only provide information within the limits, the number of token window of that LLM. And so it's external memory enables you to maintain this context so that you can feed it the relevant part of it to the LLM when necessary. That way the LLM can remember because your external memory is keeping the history and can provide it to the LLM when needed. Also, it allows you to decouple the compute, that's the LLM, in quotes, intelligence of the agent with its storage. So you decouple them so that you can modify each one independent of the other, and such modifications do not, when the modification of one does not necessarily need to affect the other, right? So it allows you to decouple those two components of your agent architecture. Any questions so far? All right, so we move ahead. Now, what is the typical architecture for AI agent memory? Well, AI agent memory has two broad categories of memory, the in-context memory and the persistent memory. The in-context memory is short-term, is volatile. It's short-term in that it just while the LLM is processing, is volatile in that it doesn't persist. Once you finish processing, it's gone. And then, I mean, it's just the information that is currently in the context window, information in the LLM prompt. Once it finishes processing that prompt, it's gone. So it's volatile and it's short-term. Then there's persistent memory, which is long-term, is durable. I mean, it stays. You can that information is available for multiple turns. A turn is like you user prompt, LLM response, or could be user prompt to call LLM response. That is a turn. So information stored in persistent memory is available over multiple turns. Thereby, it allows the LLM to have that context of concern history and so on. It helps to overcome some of those challenges that we talked about earlier when we were talking about why LLMs need external memory. And persistent memory include external databases. There are essentially external databases that store that information, which can be available across sessions, across turns, right? And what is the execution path of an AI agent when you have integrated external memory into it? So, well, typically there's perception where the LLM gets the input, and of course, it infers the intent, and when necessary, it retrieves the relevant information, assuming you need to retrieve information maybe from a document or give additional context from a document or from the internet or from a vector database, as the case may be. Then the LLM reasons, takes action, and it gets the final result. Then the relevant information is persisted in the external memory. That's the storage step. I say relevant information because you may decide to store the entire LLM output, or you may decide to store some aspect of it. It depends on how exactly you build the agent. So you while building, you need to figure out what exactly is relevant, and that's what you store. The truth is that storing everything ensures that you don't lose anything. But then, I mean, you require resources to store that information. So how do you need to manage that memory? Otherwise, it could become bloated, which might even make the your agent less performant. Any questions so far? Okay, we'll move ahead. Now, what is the taxonomy for memory in AI agents? Here, we are focusing more on persistent memory. So we have semantic memory, which is really it has to do with general facts, general world knowledge. Who is the president of Egypt, for example? That's a fact. When was the final of the last AFCON played? That's a fact. So all that, what is my name? That is a fact. When did KodeCamp 5X start? That is a fact. Who is the program manager for KodeCamp? That is a fact. All those have to do, those are things that are stored in semantic memory. And then we have episodic memory. Episodic memory is related to episodes, things that have happened, right? So episodic memory is where the agent stores his personal history, its execution history. This happened, that happened, that happens as the agent executes. Those make up its episodic memory, of course, when they are stored. And then we have procedural memory, which is really about how it's about like how the agent should do different things, workflows, procedures, and skills. So the procedural memory enables the agent to acquire skills, enables to learn and remember how to achieve different intents, how to carry out different tasks, how to carry out different steps in a task. So that if he has done this before, this way, and there was a failure, and then he did it this other way, and there's success, he learns that this last way is the correct way to achieve that intent. And so if that knowledge is persisted, it forms procedural memory. Well, procedural memory could also be provided in the prompt itself. We'll get to that. We'll get to that as we talk further about memory and context management in agents. Now at this point we are at the core of today's class. Today's class will be more about discussion. Yeah, don't be quiet with your question or comment.
Yes, so from what you just said now, you mean that semantic memory and procedural memory can put together, let's say from semantic to procedural, and they can come together to form the episodic memory, since the LLM has been working with the two of them. So the steps that's been taken by someone has become very familiar to the LLM, so it can as well use what is gotten from the semantic and the procedural to build the
Not necessarily.
okay.
Not necessarily. The episodic memory is just a record of what the LLM has done, what has transpired as this, not the LLM, as the agent.
Okay.
The agent's history, as the agent is executing what has transpired. That is what is stored as episodic memory. Now, episodic memory could contain aspects that should or could be persisted as semantic memory, as well as information that could or should be persisted as procedural memory. Right?
Okay.
As we go further, we'll see how you could, from your episodic memory, extract the contents that could become part of the procedural memory.
Okay.
Okay. Does anyone else have any question or comment on what we've talked about so far today? If not, then we move to the discussion. Today's class is really about us discussing. We're not going to run any code. In the next class that we'll have on Saturday, essentially what we're doing today is what we should have done on Tuesday, but unfortunately I was not available. So the next class to cover for this week will be on Saturday. So that's when we will look at code examples. But today we are just going to discuss. And so the discussion is this: for each of us here, think about, if you remember in the stage zero task, you not that you actually did it. You brought out use cases and for agentic AI and so on. And so here today, I'm asking you to think about one of those use cases. Just pick one of them, any one of them that you would like to. And then you need to tell us what that use case is, and then tell us whether memory integration will be beneficial in building the AI agent for that use case. And if it would be beneficial, then let us know whether a single type of memory would suffice. Now, by types of memory here, I'm thinking of semantic, episodic, and procedural. And tell us why you think, if you say yes, that a single memory type would be sufficient, tell us why. If you say no, a single memory type would not be sufficient, tell us why. And either way, whichever one you say, it will be good to tell us what type of memory you think would be best, of the best value in this use case. And then also tell us the examples of information that you would typically capture under each of the memory types you mentioned. And then the final one, okay, let's finish this one before we look at the second question. So for the first question, all of us, we are going to speak. Who would like to go first, or should I call? Would anybody like to volunteer to go first? Did I call before? All of us will speak. Okay, so I guess I'll call. I'll start from the list of participants from below. The first name from below is Samson. So Samson, could you give us your own? Samson, are you there? If Samson is not there, I'll call the next person. This time I'll go from the top. I'll be alternating top to bottom like that. Adobe, give us yours. Am I audible? Can you
Yes,
hear
you
me?
are.
Okay.
What's
Uh,
the question again? You said
it's showing on the
stage
slide. It's
zero
showing on the
assignment.
slide, right? In stage zero assignment,
Okay.
I asked you to think about some use cases from your experience, right? Now, I'm now saying pick any of those use cases
From
that you
stage zero to
mentioned there. And then, based on that use case, answer the question listed. Leave the last question about assuming the information contained in semantic memory is all consistent with no. Just the first question with its subs. Just tell us based on your own chosen use case and give us your answer to those questions.
Okay. I think um I think that memory
Well,
integration
you tell
will
us the use
be
case first. Tell us the use case first so that we
useful.
can
Okay.
tell us the
Okay.
use case so we can follow. Otherwise, we'll just be hanging without proper context.
Okay. So the the use case, I'm not sure this, I didn't use this particular use case quite often, but the use case here is um, researching competitors and markets for product ideas.
Okay.
And yes, so I think that, sorry, did you say stage zero assignment or stage one, please?
Stage zero. It doesn't matter. The use case you mentioned is fine.
Okay, it's even continuous. So I think that the memory is going to be useful, especially the semantic memory, because I think is a kind of general word knowledge, and there's not too much workflow. So I think the procedural won't be very useful. So semantic, I think. And then going to the next question. Okay, I've answered the next question. Um, yes, so the next question says if you would integrate more than one type of memory into this mention the types. Okay, I already mentioned this one. Let me go back to this one. I said yes, would a single memory type suffice? Give reasons for it. I've answered this one too. Give examples of the information that you would capture under each memory type.
So
Oh,
since you said
I
you will only
only
use
talked
semantic
about.
memory, so tell us the kind of information you capture in semantic memory for that use case.
Oh, okay, okay. So, um, it will mostly be about, since the use case is researching competitors and markets for product ideas. This is basically for product managers, yes, and especially PMs that are building applications. So I think the memory will be requiring a kind of general knowledge and facts about these competitors and what is available on the internet. Um, as someone who works on product ideas and proposals, I think the memory will be able to be generating and storing information around how these competitors, how they tend to have their measured growth, the gaps, the problems they are having, and be able to feed it into the system whenever it is needed. Let's say by me at this time. So that's it from my own understanding. Thank you.
Okay, thank you, Adobe. Now, I would like you to, if you can, try to keep a record of the response you gave now as we
Mm.
continue with the classes on memory integration in Agentic AI. Subsequent classes, I would like you at each point to try to, after each class, try to review whether
Mm.
you would like to change your answer, right? So maybe let's what I'll do is at the end of this class, I'll create a thread. So each person posts your own response. Then after each class, go back to your response and review it. Do you still stand by that response, or would you like to change it? If you like to change, well, so we keep a track and we'll see how that goes for each person. Okay, thank you, Adobe. Samson, are you available now? If Samson is not there, Olanrewaju, could you go now?
Okay, sir. Let me try. It's a tall one for me. The the question. So did you say we should only answer the first segment? I see that allow did, or you were
Yeah,
asking what
just
memory
the first,
integration.
just the first segment. Leave the question about reconciling inconsistency between two different memory categories. Leave that one. Leave the very last question. Just answer the rest.
Okay, sir. You asked considering one of the use cases. Okay. Would okay. Consider one of the use cases that you mentioned in the task season. Would memory integration be beneficial in the AI agent for this use case? Yes, I brought up 3 use cases, and the particular one that I chose in my task is about network traffic reports. So I will say yes. Memory will be beneficial if it's integrated, because sometimes maybe due to the fact that the data is voluminous, it's a daily report, and each day captures every hour on the average. So as in it's capture 24-hour reports. So that means per day we have 24 data points per entry. And each of these entries have different columns, as in different, I would say, features now that are being monitored, congestion and several of them, like the utilization of different connection points, different circuits. So, and if we want the agent to be intelligent, I would say yes. There's a need for it to have a memory integrated. The next one is, if yes, would a single memory suffice? Give reason for your answer. Well, I just taught us about 3: semantic, episodic, and coming.
Procedural.
Semantic. Okay, procedural. Okay. I actually wasn't okay, but going by general knowledge, I would say to answer the question, would a single memory be sufficient? Give reason for your answer. I would say there's a reason why there are different types of memory. I'm just trying to generalize now. I would believe that each of them has, I think from English, from general English, semantics may have to do with maybe the context, general English or general language context that may not have maybe deep meanings, deep specialized meanings.
Semantic,
So,
like we mentioned earlier today, has to do with facts, word knowledge, general word knowledge, facts.
yeah. Yes, okay, general knowledge, not specialized.
Facts.
Okay,
Just
okay.
facts. It is facts. This is
FACT, sir.
this. This is this. Yes, FACT. This is
Oh,
this. This is this. The president of Nigeria is Bola Tinubu. The president of the United States is Donald Trump.
okay.
That's a
General
fact.
knowledge, not
Yeah.
specialized knowledge. Okay,
Well, it
all right.
can still be specified. The important thing is that it's facts. What, who, where.
Okay,
The capital of
okay,
Nigeria is Abuja. The capital of France is Paris. Those are facts. That's what is in semantic memory.
okay. You see now, general word knowledge and facts. Why episodic is the agent's personal history, and procedural is workflow, procedure, and skills. I would say the three of them will be important, but more importantly, I would say the episodic, because episodic that's from the agent personal history, maybe from episodes it can that can be beneficial to his operation. Maybe for instance, on the network, there's some instances that happen, maybe peaks or congestion at some points or at some particular time of the day. I think it's very important for the agent to have this in his memory, those episodes. So I would say yes, it will need not only the semantic memory, it will also need episodic. Then procedural, workflows, procedures, and skills. I don't know. I don't think because I don't think this will be necessary because um, unless the procedure involved here has to do with the the method that the agent uses to do his things. But because the data is already provided, so the procedure that brought the data is already done. Only that the agent is working because it's just processing data. The network report that was downloaded that just gives you to maybe give some analysis and
It,
give
it
some.
seems it seems you're confusing the agents with the network. Your agent in this case is analyzing network data about the network operation, right?
Yes, sir.
So the job of that agent is to analyze a report.
Yes, sir.
So what you're saying should reflect on how does the agent analyze that report, not how does the network operation go on to
Generate
for.
the.
Yeah, it's not
Okay.
the network, it is the agent. So maybe reflect on it a bit, and if you would like to come back, fine. But either way, everybody will respond with their response in the thread. But the reason we're having this discussion is if you would like to make a comment or ask a question about somebody else's submission here in the class, please do so that we discuss and we share ideas.
Yes, sir. Am I true, sir?
Okay. Yeah, if unless you would like to come up later to talk some more. I mean that's fine. So let me ask again. Samson, are you available now? Okay, Samson seems to just have logged into the class, but it's not here. Daniel, your turn now. Daniel, are you there? If Daniel is not
Yes,
available, okay, all right, go
I
ahead then.
actually but maybe I'm driving. I'll
Oh,
you can
please,
just
don't
I'll
worry,
come
don't
back.
worry. If you're driving, it's fine. Don't respond. Please focus on driving. So
Right.
I'll call the next person then. Nancy, please go ahead. Nancy, are you there?
Yes, sir. Okay. Good evening, everyone. So, my stage zero tax, what I proposed, or what I wrote about was an education, an AI agent that helps or uses helps students with their education. So basically, what it does is that the student gets to answer a set of questionnaires, and from there, you're able to know what kind of the preferred learning style of the student. You are being able to determine the preferred learning style. That's either if the student prefers video learning, audio learning, or maybe like text-based learning. And I feel that a memory integration will be very efficient here because the agent has to remember the kind of learning style that is the student works better with, so that it can help the student in that journey of its learning. For the I think that the single memory type would be okay because um we want the agent to focus on one thing.
Okay, so which of the memory types would you use now? Which one? Which one would be
I would
that single
use
one?
the procedural.
Okay, so what type of what examples of the type of information that you would capture in the procedural memory for this use case?
Like I said, everything is basically going to be text based. So it's just going to be like a set of
Example,
questions.
example in the sense that okay, I'll capture the age of the student. I'll capture
Okay,
when last they had breakfast,
okay,
kind of thing.
okay. So I'll capture the age of the student, the class of the student. Um, I don't think the name is essential, or maybe the students can be given an ID that is unique to the student. Um, then I will definitely capture the questions and the specific answer of that student.
Now, information like the name. Okay, you didn't say name. You said the class of the student or something, right?
Class age.
Okay, the age of the student. Are those things? Are those the kind of information that um are captured in procedural memory? If that's the kind of information that you feel should be captured in this agent, do you think that procedural memory matches that? Anybody can respond. Nancy, you can if someone else can also respond to this question. So Nancy wants to be able to capture information like the age of the student and similar such information. Yeah, Adobe, you want to respond, right, please?
Yes, I think that the semantic memory will work because it's mainly about general word knowledge and facts. So since it's talking about age and all of that, um, it's kind of fixed and maybe um, my name is John Okoro. That sounds like a fact. So I think semantic will work.
Okay. So do you agree with that? Or does anybody disagree?
I think I agree.
Okay. So I agree to essentially the information you're mentioning are about facts. So those would be for semantic memory. Okay, thank you, Nancy, for that. So I'll call the next person now. David, I think, is driving, right? So Kenneth, please go ahead.
All right. So my stage zero task was a social media discipline agent, and I would. So the question is, consider one of the use cases that I mentioned. Okay, what's memory integration beneficial? So actually, I will use
Tell us the
three.
use case first. Tell us the use case first.
Okay.
So that
Okay. So I will use the I'll use the semantic in my memory,
but you
and
haven't told us the
I
use
will use
case.
it to.
You haven't told us the use case, so we can't follow exactly what you're saying.
The use case as in my stage zero and my tax.
Oh, you already did?
Yes.
Oh, I missed that. Sorry.
Okay.
Sorry.
Okay. Okay. Yeah. Yeah. Yes. So, okay. So now let me start again. My stage zero tax was using a social media discipline agent. So like that was my use case, and I've thought that I will use the semantic memory to I'll use it to store um, articles on habit loops, and maybe if a user um, if a user is bored, maybe during like a specific like period of time, and like that user probably maybe like gets like triggered, I want to store those kinds of like information, and I will also implement the um, episodic memory for recalling specific moments. Maybe what's happened during last Tuesday at a specific time. Um, did the user felt lonely or like scrolled for a specific hours? And finally, I also use the procedure memory, and the use case for that to be to find the sequence of steps um, when the user is craving to use his phone whilst maybe it's not time for them to use their phone. So these are the three memory cases that I will um, I will use. But I have a question. I have a question.
Go ahead, please.
Okay, so now this ones um I don't know if they are different from the semantic, the procedural, and the um, semantic, the procedural, and the
Episodic.
episodic. Yes. So, and I'll also have a case for using the probably for using the persistent in my memory. So,
Oh,
are
these
they
are
separate?
these are
Are they
all what these are all persistent when we're talking about when we say semantic, and we are really referring to persistent memory, right?
Okay. 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 And I also like want to store the users like information are within the database using the persistent memory. And for the short time context, maybe things which are not um or that's not relevant, that does not need to be kept in the database. I would want to use that for that. So yeah, I think I'm done. Unless maybe now you want to like punch holes in what I said so that like we could go for a long run. I'll be glad.
There are no fun. Just that, I mean, if it's not relevant, there's no need to store it in memory. Yeah, if
Okay.
it's in the working memory, I mean, while the LLM, for example, is generating as your agent is executing, it's there, and after that, you don't need to persist it. You really need what you
Mm,
need memory for are things that you need to persist so that they are available across multiple turns or across multiple sessions. For example, if in a session, the agent while trying to address a user query, the agent gets to it becomes clear that the user only wants concise responses. The user doesn't want verbose answers. The agent can learn that. So if the agent learns that and persists that information, it enables the agent's subsequent interactions with the user, enables it to provide a response that would be better suited to what the user wants. Now, I'll leave you to figure out whether such an information that the user wants, concise answers, the user prefers concise answers, should that be stored in semantic memory or in episodic memory or in procedural memory? Let's just hold this question when we have gone to answer that question. Um, Lawrence, you're up next.
Can everybody hear me?
Yeah, I can hear you now.
Okay, so the case study I'll be using is not what is in my stage zero task. I don't know if that's fine.
It's okay.
All right, so there's this friend of mine that is building, I won't call it an agent, more like a chain of operations where he looks for job on Upwork, then he gets the job description, he pastes it to this programmatic something, and the thing generates a it's like a proposal for him based on his data. So he provides this thing with maybe the project he has done and the his skill set. So I was just thinking of an idea around that to make that kind of agentic where the agent will do the job seeking itself. So a search on LinkedIn, on other job sites, then using the information he has about you, that skill set and the project you have done, it draft out maybe a proposal or maybe apply for the job by itself, and when the job is being applied for, to send you an email that this job has been applied for. Then if by any chance you get to the level of an interview, you also give feedback to the agents that okay, this thing you did got me it got me the it got me an interview basically. So for that's the concept, that's the use case that I'm trying to talk about now. Then for the memory, I feel you mentioned that semantic memory is about facts, so I feel that this will be useful. I feel that LLMs generally they work with this type of memory because most of the things that they know, I mean, they know that the sky is blue, they know that things is this and that is that. Then for this context, the semantic memory will hold information like this user is looking for this type of job. Like, okay, I'm a Python developer and I'm looking for Python development jobs or backend development with Python. It's like a fact that the agent should know, I feel. Then the other type of memory is the episodic, so experiences of the agent and the workflows that it has done. So let's say the agent visits LinkedIn by 10 p.m. in the night, and it sees a job on LinkedIn, and he applies for the job, and the job gets the user an interview. The the agent knows that, okay, this time or this kind of jobs have more, will I say, ROI, or is more beneficial to, so it kind of tracks that workflow. So it stores that in the memory that, okay, this works better for the user based on feedback. Then the other memory is the is it
Okay,
press
just
press
just just a question. In this case, about the agent learning that so and so type of job has a higher ROI, and so that so you should try to prioritize applying for such jobs. Would that
yeah.
be stored in episodic or procedural or semantic memory? Which type of memory will best be used for storing such information?
Okay. So first, the agent will remember that, okay, it did this and that to get this type of job. So that is remembering the process. I feel that is under episodic. Then once it's finalized that, okay, this process result to this outcome, it can now store that in the the procedural, where he remembers how to do something again. So he kind of stores that in a place where if he wants to repeat the process, he knows where to go and just do the same thing instead of having to move here and there. I
That's
don't know
very
if
good. That's a very
okay.
good answer.
Okay, thank you, sir. So that's just, I think, have I answered everything? If
Yeah, I think you have. I think you have. You didn't follow them in sequence, but I think you've answered all.
okay, all right, sir.
Who hasn't gone yet? Daniel, have you given us yours?
No, I haven't. But I'll
Okay.
just try and speak briefly. So, good evening, everyone.
Evening.
So, for my schedule task, what I came up with was for to create an agent that will serve as an assistant to a facilities maintenance team. I hope I can be here though.
Yes, we can hear you.
Okay, thank you. So, the agent is supposed to help a facilities maintenance team that is managing various properties. I hope everybody is conversant with facilities management. But ideally, the facilities team, they manage everything about the building or the property. Like if you enter an office complex, you'd expect that the environment will be clean, it will be welcoming, the temperature is set right, and everything that makes it conducive for the staff to work in that building is provided. So the idea is for the agent to okay. So for me, I work with a company that has branches around the country. So my main focus was to have the agent extract requests that come through emails to our team, and then our team. I mean, then once that that information is extracted into a database, then we can track the issues that come up and then solve them as time goes on. And also, I mean, the idea is also to help to prioritize the issues as they come along. Yes. So that was my um, stage zero task. So yes, memory integration would be beneficial to the agent, and the reason is okay. The next question is, would a single memory type suffice? The answer will be no for that, and the reason is, I mean, we for the agent to really be useful. For example, for a particular branch, it would be great for the agent to keep track of the issues that are persistent from that particular branch. So in this case, it needs that just a second. It needs to have the ability to recall issues that are usually reported at that branch. So that's the episodic memory. Then you have the semantic. The semantic, I'm looking at, let's say, fine, there are facts, but if you can give the agent, like let's say the company policy, and then let's say you can load manuals, let's say how a generator set works, how an air conditioner works. I mean, if you can give it that kind of information, then I would put it under semantic memory so that it can always, I mean, pick up those facts from, I mean, that memory and then use it to help to take decisions. Okay. And then I think the other memory type was you have semantic, you have episodic. There's another memory type,
Zero.
procedural. Yes, thank you. So with that one, you are looking at processes. So of course, when an issue is reported, you need to follow a certain process to have it resolved. So that type of memory, procedural memory, will also be needed. I mean, to make the agents efficient. Um, so examples of the information that we capture under each memory type. Okay, so I think I've given a few examples. I mean, along the line as I spoke, but for let's say semantic, I'm looking at company policy, equipment manuals, things like that the agents can use to take a decision. So, for example, an AC is repeatedly reported faulty, and then maybe from the reports you realize the capacitor is always the issue, but by digging deeper using the manual, maybe it can tell you this time around, look at this particular component in the air conditioner, and then that serves as like an additional support to the team. And then for procedural, an example would be supposing an issue is reported, a plumbing issue is reported. So what are the steps? Um, the kind of information that you need from the user that should be extracted, and then you're looking at the next item. Are you going to contact a plumber? Can you allow the agent to contact the plumber? I mean, that's also another possibility to look at. And then the episodic. For one of the things I realized about some of the branches is that during certain periods, because they are in industrial areas, they have their voltages going high. The AVR reads very high voltages. So at least with that, the agent can learn and pick up. I mean, things that maybe human beings will not be able to pick up. But I mean, pick up these should I say things that are on the quiet, so that it can help the facilities team to also make informed decisions. So for such, for example, for such a branch that maybe during a certain time the voltages go high, what are we going to do? Are we going to install a higher capacity AVR, or rather request that that power line, the branch is changed from that power line to one that has less load? So that's an example. I think I've spoken a lot, so I'll leave it here. Thank you very much.
Thank you for that, Daniel. David, are you still driving?
I have to park.
Okay, so
Thank you.
since you're back, it's your turn now.
Okay, thank you, sir. I think you're actually mistaking me for Daniel. Daniel was the one driving.
Oh, sorry about that. Oh, sorry
Right,
about that.
so, let's stop. Okay,
I didn't hear
so
that.
So for my use case, can you hear me clearly?
Yes, I can hear you now.
Okay, for my use case, which is customer support, response management, yes, in mobile app or any mobile app at all. So I think memory integration would be very beneficial. Yeah, reason because um, the agents need memory uh, because users may report issues uh, multiple times. Yes, because even as a user, I've reported issues over an issue on an app, so multiple times. Yes, and without memory, it's possible that the agent will treat every message as a new one. Yes. So, and I also think it can remember with memory, it should be able to remember previous complaints. Like if I've made complaints previously, maybe last month or last week or 2 weeks back, we should be able to remember previous complaints, known bugs on the apps, and past responses that have been provided to the user. Yes, which also will help improve speed and consistency. And then would a single memory type suffice? Mm, I don't think a single memory type will be enough because uh, from my experience with customer support, it involves different kind of information. Yes, some information is temporary, uh, like the conversation, while some need to be remembered long term. Yes, some are short, are longer. Uh, known issues or user history. Yes. So I I think single memory type will not suffice. Yes. Then if I would integrate more than one type of memory into this feature, mention the type. Okay, so if I would do that, uh, one I would go with is the episodic memory. Yes. The reason because this will capture past interactions with the user, such as previous complaints, uh, maybe repeated bugs if the user is consistently experiencing constant bugs. Like, say, for example, with transaction apps, maybe failed transactions or not able to get history of transactions that have happened previously, is constant bugs like that. And or whether the issue was escalated before. Yes. So the need for episodic memory will come in handy here. I think this will help the agent to personalize responses and avoid asking the user the same questions again and again and again and again. Yes. And then another is a semantic memory. Um, I would say this contains general knowledge, like frequently asked questions, same mobile game non-bugs, common fixes, information about app features. Yes. This will allow the agent to answer questions quickly without human involvement. Yes. So the need for semantic memory. Then think there's also I think there's also something called contextual memory or short-term memory. Now, for this kind of memory,
Context is essentially um, the surrounding information you provide. So that context can come even from these other memories that you mentioned. If you pick information from maybe the episodic or maybe the semantic memory, those could form part of the context that the agent uses to address the specific user request.
Okay. That's clear. Thank you very much for that. Then I think the next one is okay. Assuming the information contained in semantic memory is not consistent with study memory.
No, that's the final question that I said that you shouldn't answer. I would like to also have that as a take home task. So as a take home task, you just think about it yourself. Think about it. It's something that will come up in just a moment you speak. Let me finish saying this. In one of our subsequent classes, this situation will come up. Assuming you have a conflict in the information in one memory. Let's say let's say it's an election in a given country. This person is currently before the election, the agent stored this person as the president, and then after the election, let's say some other person becomes president, and the user asks who is the president, and it gets that this other person is the president. Now you find that you in the episodic memory, for example, if you store each of those interactions, you have two different persons mentioned as president, and even in the semantic memory itself, at some point, this person is the president, and then now a different person is the president of that place. Let's assume there was no indication of the time for each of those. How would you resolve such a situation when there's conflict, even in the same memory or across different memories? How would you resolve that? Just think about it. We're going to discuss that still in one of our coming classes. Yes, Nancy, please go ahead. What was your question or your comment?
Okay, sir. At the beginning, I was having network issues. So I don't know if you had addressed my issue on my non-promoted tax because I didn't hear you well.
I said let's take that up on Discord so that we don't hold up the class.
Thank you, sir. Okay.
There was somebody else that also mentioned something else. I said, let's take that up on Discord. So please, for those, you and that other person, I don't remember who exactly, please send me a DM so that we can discuss and find out what exactly the issue is and resolve it. So, ladies and gentlemen, that's essentially what we have for today's class. On Saturday, we are going to dive into, we're going to look at these memory classes in details. Well, I think we'll start with semantic memory. We'll look at it in more detail, and we'll look at code examples to illustrate it. And then we'll move ahead from there. So does anybody have any further question or comment? Like I mentioned, I'll start a thread on the Discord channel so that each of us should post their response in that thread. And so as we proceed to move ahead with our yes, Kenneth, just a moment, as we move ahead with our classes on memory management.
Okay.
Just a moment, Kenneth. I just want to round off what I'm saying. So as we move ahead in our classes on memory management in agents, after each class, you review what your response is and see whether, in the light of what the new things we have learned, whether you want to change that your response to the discussion question of today, or you to maintain that. Okay, so go ahead, please, Kenneth.
Okay, so I wanted to ask, what is the difference between creating an agentic application on the web and on the mobile app? So, like, could you throw more light on that for me? Or I don't know if like that is the same, if like they use the same approach, or maybe if there is a different pattern.
Just for disambiguation, do you mean when you say web and mobile, do you mean the platform from which the user accesses the application?
Yes, please.
Well, those are simply web mobile just has to do with your front end. Your back end is the agent, and the agent is the same for either one. So the agent is the agent. Now, web or mobile are just delivery mechanisms, delivery platforms. They can both communicate with the same backend, which in this case the agent itself is the backend, is in the backend. So you could build an agent service in your backend, and then it can be accessed from mobile, from web, from desktop, whatever.
Okay. So like we would just like create it as we use a RESTful
The same way you build an application backend and maybe either a
API.
REST
Yes,
REST
I
back
get.
REST API or GraphQL API, as the case may be, you build it out, you build your agent, you package it into an API, and you deploy it, and then any front end can talk to that agent. That's it.
Solid. I appreciate.
Okay, so does anyone else have a question or comment? If not, then we can call it a night. Okay, I guess there's no other question or comment. So good night, ladies and gentlemen. See you all same time on Saturday. That'll just be a one time for this week. Next week we move back to our Tuesday and Thursday. So for this week, we'll complete this week's topic on Saturday at 8:30 p.m. So see you there.
All right, so thank you, sir.